Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will apply what we know about transformations of functions. So I'm going to go through two things. One where you draw a transformation and one where you write an equation. So let's look at this one where we're going to draw a transformation. So I've given you the graph of fx and I'm asking you to draw a function gx if gx is equal to f of x plus 2 minus 1. So let's translate this into English. This basically means gx is the same graph as fx except it's been transformed. So we know that putting the plus 2 in the brackets means that it's gone 2 units to the left. Remember, in the brackets sort of goes the opposite way that you'd expect, and the number outside the brackets, the constant by itself, shifts it up or down. And that goes the way you'd expect. So because this is negative, it's gone down. So gx is the same as fx, except it's been shifted 2 units left and down by 1 unit. So to graph gx, I just need to take each point on this black curve and shift it 2 units left and 1 unit down. Now, of course, it's going to take me forever if I shift this point 2 units left, 1 unit down. Then this point, 2 units left, 1 unit down. This one, 2 units left, 1 unit down. It's going to take forever. So let's look at some points that sort of stand out. So an example of a point that sort of stands out that's easy to work with could be this point here. And sorry for my drawing. This was supposed to have an x-intercept of 3. So this point here, where the x-intercept is 3, I'm going to move that 2 units left and 1 unit down. That point ends up over here at minus 2. So then we can look at like turning points. So this turning point here, 0.15, I'm going to move it 2 units left, so it's going to be over at minus 1, and down to 4. So it will be there. All right, then we can look another point that's easy here, an x-intercept. So I'm going to move it 2 units left and 1 unit down. So it's going to go through this point here. We've got another easy point here, 3 minus 2. So I'm going to move that point here 2 units left and 1 unit down. And then I can do the same with this point, move it there. You basically just have to pick as many points as you need in order to be able to graph this. Now that I've got that, what I'm going to do is join them up. So it's going to go like this. Remember, this point here was where the maximum move from. So turning points, it's going to go down like this, up again, and then it's just going to keep going up forever. And that's the graph of gx. So this is just a rough sketch. It doesn't have to be fully accurate. I can't do it fully accurate on the iPad, but there you go. That's all you need to do. So let's look at now an example where I give you the two graphs and you have to find the equation of one in terms of the other. So we're going to do this question here in which we are going to write gx in terms of fx. So that means we're going to write gx equals something that has f of x's in it. So when you have to write one function in terms of the other using transformations, all we need to do is ascertain the transformations. How far has it gone left or right? How far has it gone up or down? To do that, like I was sort of saying on the previous slide, we need to identify some corresponding points. So here we'd look at like a point like this where the line part sort of starts and this point here. And we look at how did we get from fx to gx. So how do we get from this point to this point? So to go from this point to this point, we need to go across 3. So we need to go 3 to the right and 4 up. That's really all you have to do. So gx is just the same as fx, but shifted 3 units right, 4 units up. And we know how to write that in terms of transformations. Transforming something 3 units to the right, we would write f of x minus 3. Remember the horizontal part, what goes in the brackets sort of goes the opposite way that you'd expect. So we went right, but it's a negative 3. And then we also went up 4. And that's the constant that does work the way you'd expect. Up 4 is positive 4. That's all you need to do here. If you had heaps of different points given to you, just pick one that corresponds. Look at like the maximum turning point of both functions on the minimum turning point of both functions. If there's only one y-intercept, look at the y-intercept of both functions. Just find a corresponding point, ascertain the transformations, and then you'll know everything you need to know. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.